Hi all, this is the badging video for the TIG welder here at MakeHaven. So welding is where you take two pieces of metal and actually melt them to make them connected, perhaps into one piece of metal. Soldering, brazing, those are where you heat it up, but it actually doesn't quite melt. So that's the difference. You can do a fusion weld where you just take two pieces of metal and melt them along the edge until they're one piece. Or you can add more filler metal. So these would be your two parent pieces of metal, and then you add some filler of a similar kind of metal to connect them. And that's most often what you're going to do. We have a lot of different kinds of welding here at MakeHaven, so you might wonder why you would use a TIG welder. TIG stands for Tungsten Inert Gas. And to just sort of explain what that means, the idea with TIG welding is that you have this torch, and in it there is a rod of tungsten. Tungsten can get really hot without melting, which is why we use it. And there's also inert gas, in this case argon, getting blown around it. So if you're familiar with other kinds of welding, you know that when the metal is molten, it needs to be protected from oxygen so it doesn't oxidize. And so in this case, we blow argon around that molten metal so that while it's molten, it can't take in oxygen. And so it can cool in an oxygen-free environment. So that's the TIG, tungsten inert gas. The way that this works is compared to, say, a MIG, is that the filler metal you supply with your other hand. So this just melts the metal, but it doesn't also have a spool of wire getting fed into it. You do that with your other hand. In terms of determining when you would want to use TIG, on the one hand, it's probably the most difficult kind of welding because it requires using both your hands and your foot. So that's a lot to coordinate. And often it isn't as fast as, say, MIG welding, but what it does offer is the ability to more easily do thin metals, different kinds of metals, and doing really precise, and perhaps if you get good, doing good looking welds. So it allows a level of precision that isn't quite possible with stick or MIG or other kinds of welding. So those are some of the reasons why you might choose to use this style. In terms of safety when TIG welding, you don't have to worry so much about splatter like you do with MIG or with stick. But you do need to worry about the incredibly bright light that TIG welding produces. So you need to make sure to wear a welding shield over your eyes and face. And you're going to set the shade setting probably all the way up. But we'll look at that more closely when we get the hood set up. And you can get a sunburn from it. So you need to make sure to cover your skin that is exposed to the light. So that's a welding jacket, maybe a cap to make sure your ears are covered, and gloves. If you're sitting at a table while you're welding, then it may be safe to not wear long pants, for example, because your legs aren't being exposed to the light and there's not much risk of splatter. In general, though, when welding, it's a good idea to make sure that you're wearing clothing that covers all of your skin, that's non-flammable, and that sparks won't go through, meaning it's made out of cotton or something organic, not inorganic things like vinyl or polyester, which hot things will just melt right through. Closed-toed shoes are also a good idea so that any sparks and things can't just fall into your shoes. And again, things like sneakers are made out of plastic, so the sparks would just would just melt right through them. The other consideration is the heat that this produces. So when you're welding, the material that you are welding and maybe the surfaces around it will get quite hot. So it's important to wear gloves and be mindful of the things that you're touching. All right, so first we're going to cover some of the more boring information before we get into the actual welding. So first of all, we're going to look at the metals that you can use to weld things together. So over here we have some of the metals. So as you can see, we have a few different options here, and we may certainly get more over time. This one is labeled as ER70S-6. ER70S-6 is generally used for mild steel welding. So you could use this for most steels. However, you'll see that it says an 1/8 inch on this. And an 1/8 inch is pretty large. Our machine can put out about 250 amps max, and an 1/8 inch is sort of pushing that capability. So there may be times where this is appropriate to use, but in general you might want to use a smaller filler metal. that is easier to melt. So this is the same thing, just in 16th inch size. So you can see here that it says ER70S-6, mild steel filler. And next to that we have, this is stainless steel 16th inch TIG welding rod, ER308L. It's one of the most common welding rods for stainless steel. It's great for 304 stainless. You can also use it for 200 and 300 stainless steels. And then here we have ER4043, which is for aluminum filler. It's also a 16th. And this can be used on most aluminum applications. In general, welding of 2000 and 7000 series aluminums is generally not recommended. So these are some basics that we have. If you're looking to weld other things like titanium or chromoly, then you should research what filler metals are best for the alloy metal you got. In terms of the thickness, in general, you want to make sure that your filler metal is thinner than the material that you're welding. So if you're doing thin sheet, you want to make sure that it's thinner. And then after that, in general, the higher the thickness, the more amperage you'll need to use. So thicker base metal or parent metal means you need a thicker filler metal, but you also need to use more amperage to do that. All right, so now we will look at the tungstens that are actually used here. So we're going to look more closely into this guy. So we have this cap on the back, and this helps seal in the gas and just covers the back end of the tungsten. So here you can see the blue paint on the back side. In general, these are the tungstens that we have are blue. And as you can see on this box, the blue ones are 2% lanthanated. These are general good all-purpose tungstens. You're welcome to get your own tungstens if you are interested in doing more specialized things. But bear in mind that some of them are actually radioactive. They have some radioactive elements in them. So you just need to be much more careful about dust control when you're using those. So it's especially important to make sure that you grind those on the special TIG grinder and not on the bench grinding wheel in the metal shop. All right, so now we can screw this off, and this is just a cap that goes on the front end. What this does is it directs the gas around the weld. There are different sizes of these caps that we have in the drawer available. Smaller is good for areas where you have a smaller weld puddle and you're able to get close. If you're not able to get so close, because say you're doing a fillet weld in the corner of something and you're a little farther away, then you want a wider cap in the front to make sure that you're covering your puddle. So here you can see the tungsten, and we'll look at sharpening that in a minute. The tungsten goes through a collet. So here you can see this collet that it goes through, and the collet goes through this collet body, and you can see the holes around the sides for the gas to come out of. So those holes are one way of letting the gas through. There are other options for torches, specifically having a gas lens, and that's just sort of a fancier version that makes sure that there's nice smooth flow of the gas. And that is nice, but it's just more expensive and in general not necessary for basic welding. So we're going to put that back through and put the cap on the back side, and also there are different length back caps in the drawer. So this back cap, when you screw down on it, pushes the collet into the collet body, locking the tungsten in place. So if you want to adjust the position of the tungsten, you unscrew this, unscrew the back cap, and then you can slide the position of the tungsten. So we're screwing this back on here, and we want the tungsten to stick out no more than the diameter of this hole in the front. So in general, it's a balance between visibility. You need to be able to see the weld that you're doing and having good shielding. So we're going to start with right about there. That's maybe about the diameter of the cap that we're using. So I'll screw that back in, and by tightening down on this back cap, it will lock the tungsten position in place. All right, so there we go. You can kind of see that. Now we'll look at sharpening the tungsten. So I loosen the back cap and can now just pull this right out. And this tool, this grinder, lives in the top shelf of those TIG and Forge accessories, and we're just going to plug it in. And here you can see that this is a special grinder Dremel thing that keeps the dust contained in here, so we need to be less worried about the dust coming through. And you can see that there's different sizes, different size tungstens that you can use with it. So these, the ones that we have, are 3/32 size. If you wanted to change the size tungsten, you would need to get your own collet bodies and collets to make sure that they fit. So 3/32, it's saying, is the 1, 2, 3rd from the right hole. It has different angle options too, all the way from 15 up to 30 over here. There are lots of different opinions about different angles and its effects on the welds that you're doing, but 22.5 is kind of middle of the road, so that's where we'll start and run the 3rd hole. In general, the colored end of your tungsten goes in the back, so you don't grind it off and you can see what it is. And then we go in this hole and we're gonna turn it on. And in here, we have this abrasive disc that we're gonna grind against. So it goes into the hole, and then right down there. And after turning it around a few times, you can see that we have a nice sharp point now. Focus. Well, you may or may not be able to see that it has a nice sharp point. And then you can play around with different angles. There are also replacement discs in there for once this wears out. Tungsten is very hard. And this is nice because it collects all the dust. So if you are using a tungsten that has radioactive elements in it, that it becomes less of a worry. And as you'll find, you actually need to grind the tungsten quite often while especially as you're learning how to TIG weld. So you may just end up keeping that out, because every time that you accidentally touch your tungsten into the weld pool that you're welding, you need to regrind it to make sure that it has a nice point again. So just keep that in mind. So I'm just gonna slide this back in from the back. Gonna open up the back cap and slide it in pointy end first, just like that, and then set our stick out again. So we'll put you in but not tighten it down, set our stick out right about there, so we're just coming out about the diameter of the cap. All right, and this is good to go. So now let's look more closely at the machine itself to figure out all the bells and whistles on here. So first we need to plug it in. And to do that, we're gonna find the plug labeled TIG, which is this one. And we're gonna unplug the forge that we have plugged into the wall. All right, so TIG is now plugged in. But before we turn it on, what we always wanna make sure to do is to have the water cooler turned on. So down here, actually that's not quite true. So now this is plugged in, and if we were going to start TIG welding, then we would need to make sure to turn that water cooler on too. The water cooler pumps the water through the TIG torch to make sure that it stays cool while we're welding. The way this kind of welding works is it takes electricity and runs it in a loop through the tungsten coming out of our torch here in an arc that comes down into the metal. So that's the white, the bright blue arc that you can see that's generating a lot of heat in your material to melt it. And then it travels to this work clamp that you need to have clamped on your material so that the electricity can form a loop. So it's effectively a short circuit, which in general is a bad thing because that would heat something up, but we're using that to our advantage. So there are two ways of controlling the TIG when it's in operation. One is using the foot pedal down here. The other is using the trigger on the torch right here. It's largely preference which one you want to use. The more commonly used one is the foot pedal, but if you want to use the hand trigger, then that will activate these 4 knobs. So these 4, as it says right here, are only for use when you're using the hand trigger or the torch trigger, not for the foot pedal. So foot pedal, they're all set to 0. But let's say you want to use the torch trigger, then there's 2 modes you can use it in, either 2T or 4T. 2T and 4T. And that stands for 2 touches and 4 touches. So 2 touch means you would pull the trigger and it welds and welds, and you let go and it stops welding. 4 touch means you pull it to start it. So 1 touch, 2 touch, and then you pull it again to stop it. 3 touch, 4 touch. And if you have it in either of those, so the way you control which one you're using is you plug it in here. So here we have the pedal plug, but if we had the torch trigger plugged in instead, then you could select between 2T and 4T depending on which you wanted to use. If you were doing that and you had the torch trigger plugged in, then that activates these 4 knobs, and the use of those 4 knobs is described well in the manual. So looking down at the manual here, we can see that we have the start amps and then up slope, down slope. So you can sort of see all those pieces in there. And as you can read about in the manual and experience on your own, those will affect the different weld qualities. So you can select which style you want, the 2 touch or the 4 touch there. Or if you are using the foot pedal, you just leave it here on 2T pedal and leave all these at 0. The gas flow settings are used regardless of whether you're using the foot pedal or the trigger torch. Here we have seconds of pre-flow and seconds of post-flow. Pre-flow is when you pull the trigger or push the pedal and the gas starts flowing before the arc starts. And that's important to make sure that the area that you're going to weld is well covered with gas before it gets melted. So in general, you can set that to, maybe a second, somewhere in a relatively low range. It doesn't take very long to cover your metal with the gas. Post-flow, in general, you want to be longer because your metal is still sitting there molten, and you want to make sure it's well covered with gas while it's cooling down. As a rule of thumb, people generally say you take the number of amps you're welding with, which will be up here, and divide by 10 for the number of seconds. So if you're welding, say at 150 amps, you'd wait for 15 seconds, which seems like a long time. In general, you can probably set it a little lower than that, so maybe like 8 seconds is probably a good number to start with. But then if you see that you are getting bubbling and nasty looking things at the ends of your welds, then you'll just want to increase that post flow. Same with the pre-flow. If it looks like your weld is not good, porous, bubbly, whatever at the beginning, then you want to increase your pre-flow. All right, so here we have the big knob right in the middle, and that's looking at just the number of amps that you're welding with. So this goes up to 250, but you can go, there's a pretty wide range there. All right, so then we have pulse. What pulse does is it pulses for you. So often when you're welding, you want to lay a bead, which is made up of individual puddles as you go along. And you can do that with your foot. You go push, push, push as you're putting the filler metal into that puddle. But what you can also do is have it do that pulsing automatically. So here you would click pulse, either off if you're just doing normal, low, or high. And then down here you can choose the pulse frequency, the pulse amps, and the balance pulse time on. So these options are only activated if you activate the pulse. We already looked at the remote, whether you're controlling it from the trigger or from the foot pedal. AC or DC is pretty important. So the more basic kind is DC, direct current, and this just effectively has the electricity flowing in one direction. And 99% of the time, if you're in DC, direct current, you're going to be doing DCEN, or electrode negative, which means that the torch will be plugged in to the negative terminal for DC electrode negative. Another word for that is straight welding. And so most of the time when you're welding, especially with steels, you'll be using DC. But let's say that you wanted to weld aluminum, then you might put it to AC. Aluminum forms an oxide layer very quickly, called aluminum oxide, and the only way to break that up is by using a quick pulse of DC electrode positive. And so AC switches back and forth very quickly between DC electrode negative and electrode positive, which is called a cleaning effect. So when it's in electrode positive mode, it's cleaning it, and when it's electrode negative, the normal DC one, then it's welding. So AC is for aluminum and lets you go back and forth. So here we have high frequency start TIG, lift start TIG, and stick. So high frequency start is the most frequently used one, and that means you can put the torch, the tungsten, right above your material, and it will use a high frequency to start the arc, to initiate it on its own. Occasionally though, you might not want to do that. Maybe you don't want to put a high frequency through your piece or something like that. Then you can lift start, which is when you select that, you lower the tungsten down to your material and it will start an arc when it touches briefly. Then you can lift your tungsten back up slowly and start welding. So you could do that if you didn't want to use a high frequency for some reason. Stick is the kind of starting that you use when you're stick welding, and that activates this knob. And if you do that, then over here we have the TIG stick welding clamp, which you could plug in down here in place of the TIG torch, and then use this machine as a stick welder. So then we have the spot welder function. So you would set that to on instead of off. And a spot welder is often for putting two pieces of sheet metal together where you're tacking them together in the middle. And in that case, you just want a pulse of electricity right on that area. And so you could do that by hand, or if you wanted to do a lot of them and you wanted them to be consistent, you would put this to on and set the number of seconds that you wanted it to hold that arc for. So then if you had two sheets stuck together, you could weld them right in the middle and weld those sheets together consistently in different spots. This knob, just for stick, is called the dig or arc force. It's when your stick gets too close to the material, the voltage starts to drop and it injects more amps to make sure that your arc doesn't disappear so you can keep welding. All right, now we'll go down here. So this is pulsing. So this is, again, is only when you're in pulse mode. Here's the pulse frequency. So that's just how many times it pulses per second. And you might be able to see, or might not, that there's two green numbers down there. It goes 0.5 to 25. So up here in the pulse, you can select low or high. Low means that it'll be looking at that 0.5 to 25. High means it'll be looking at the 25 to 500. So let's say you set it all the way in low mode and then down to the bottom here, then it would be half a pulse per second. So a pulse every 2 seconds. So it'd be like pulse, pulse, pulse. That would be pretty slowly. And then you go faster if you wanted faster pulses. And then obviously you could go crazy fast if you just wanted like lots of little pulses instead of a continuous arc. So then we have ratio of pulse amps. So that's showing the percentage of the off time. So there's pulsing on, and then in between the pulses, when it's off, this is how much it is. So it could be 95%, which would mean that when it's not pulsing, it's still almost just as strong, or you could turn it all the way down so that in between it's pretty much off. Then balance pulse time on is showing how much of the percent is the time on versus time off. So if you set it all the way up to 50, then it would be equal amounts on and off. So on, off, on, off. If you set it all the way up to 90, then it'd be like on, off, on, off. So depending on what you're doing, you may want to balance that one way or the other. And last but not least, over here with these yellow knobs, we have the hertz and frequency. These are for AC. So when you're setting it to AC, welding, it'll activate these knobs. And the frequency is how quickly it's flipping back and forth between DC electrode negative and electrode positive, the cleaning action. Let's say you wanted to swap back and forth really fast, you would set it to 250. If you want to be somewhere in the middle, you'd set it around 90, for example. And then the difference between the cleaning balance and the frequency is how fast it's switching back and forth per second in hertz. The balance is how much of the time it spends on the plus versus the negative side. So similar to over here when we're pulsing, the time on versus time off. So let's say you wanted it to be much more cleaning, then we would go over to this side. So then it would spend 90% of the time doing the DC electrode positive And if you wanted less cleaning, you would go down over here and it would be more electrode negative. So here is just when it's on. This is when it's getting too hot, and this is when it's drawing too much current. If it's getting too hot, you just need to give it a little while to cool down without welding. If it's drawing too much current, then you should probably change something about how you're welding. Also, as a note, on top of this machine is the manual, and it's a really good manual if you want to flip through it, or if you have any questions. All right, so first let's make sure we're hooked up to gas. When you are TIG welding, we just use argon. So you don't need to worry about the two tanks when you're TIG, you're just using argon. The way these connect is when we make sure this is off, and you should always make sure the gas is off when you're finished. These quick connects can just pop on. You just pull this collar back, and then it comes out and then pushes back in. So this is the hose going to the TIG. And then in general, for TIG welding, you need less gas flow than you do for MIG, for example. So you could be anywhere between 10 and 20. And here we just have an upper market 20, but you can be between 10 and 20 when you're TIG welding. So we're gonna open the tank. And then I'm just gonna open this a crack. And it popped up to 20. So we'll just lower it down a little bit, but somewhere in that range. This shows the pressure in the tank. So when this gets close to 0, we need to replace the tank. This is just to open it. So this just allows the gas to go from the tank out. And then this controls the amount of gas coming out. So if you want more gas coming out, you open it up. If you want less gas coming out, you lower it. And this ball goes up to the level of the amount of gas coming out in cubic feet per hour. Standard cubic feet per hour. So the ball will come up and we'll see it when we're welding to see how high it is. All right, so the gas is hooked up now. We know that we've plugged the machine in. So we can turn this on. The power switch is inconveniently located in the back here. So it's just a switch that you lift up. I'll try to show you. Down here, this blue bar. Then in the front, we can see that it's fired up. And now we're gonna turn on the water cooler. So we're gonna check the water level in the water cooler. And right now it's full. It might be hard to see, but in person it's easier to see, or you can unscrew the cap and look inside. And we're gonna make sure that it's set to TIG. So TIG is to the left. So these are ball valves, and just when if you move it to the right, it's for the forge. If you move it to the left, it's for the TIG. So now it's going to the TIG, and now we can turn it on. That water flows right through the torch and helps to keep it cool. So now we can look at the front of the machine to see what stuff is plugged in. So this cable goes to our work clamp, which is right up here, and it's in the negative terminal. So if we are doing normal TIG welding, then we want to be in DC electrode negative. So we want our torch, which is this plug, and you can see all the different things going into it, going into the negative terminal, which is that one. So someone was stick welding before this. So I'll undo you by twisting this to the left, a little tight, and plug this, our work clamp, into the positive terminal. And then take our torch, plug this into the negative, and twist that on there. All right, so now it's nice and snug. Currently, we have the pedal plug plugged into the front of the machine. The pedal plug is the more common one to use because it allows you to vary the amount of electricity going to your welding piece. But let's say you wanted to use the torch trigger for some reason, then you would just swap it out. So you plug the torch trigger in here instead. There's a long cable going to the pedal, so you can unspool that as you see fit. We're gonna get set up on the welding bench over there. So looking at all of these plugs, starting from the left, we have the electrode plugged into the negative terminal because we're welding straight, which is DC electrode negative. This is the hot water line. So the water is actually flowing around this cable all the way down to keep it cool, and then back here into the water cooler. Next, this is the gas line. So this carries the argon down into the hose and around out of our torch. This is the pedal plug because we're controlling it with the pedal. And then this is our work clamp. So this goes to this clamp, which we're going to attach to the work. And then down here you see this blue hose. This is the cool water coming from the water cooler, going down and going into our torch before circulating back. Now we'll get the safety equipment set up. So as it suggests on the wall, we need to make sure we have face protection, gloves, and closed shoes and the fume extractor. As I mentioned, this isn't very splattery, but it still doesn't hurt to have cotton pants on to make sure that your legs don't get any splatter on them. So over here we'll get some gloves. For TIG welding, it's generally nice to be able to have a more fine touch so that you can control it nicely, so thinner gloves are often okay. As a note, when you're TIG welding especially, cleanliness is very important. So these gloves might not be the best choice. Cleaner gloves might be a better choice if you're doing something important. We'll pull the fume extractor over, and then if we were going to get started, which we will shortly, then you would flip that switch. In terms of safety gear, we'll get the hood on. The hoods live right out here, up on the wall. So these are all good. We also have welding jackets and pants and caps. So I'll put this jacket on, grab the cap, and then the hoods are each a little bit different, but they all have the same basic functionalities. So the controls on the inside on this one. On the left, you can see the shade, which is set all the way up, which is fine. In general for TIG, if you want to be between 11 and 13, 11 only if you're doing lower amperage welding. Sensitivity sets how sensitive the shade is to turning on. So let's say you're outside, the sun is really bright. So if you were set at high sensitivity, it would just be dark shaded all the time. So you turn it to low sensitivity. Since we're inside, that's not really a problem. So you can make it high sensitivity. And then delay is how long it stays on after the really bright light has stopped. And that's because even when a piece of metal is no longer being actively welded, it can still be very bright and you want it to stay shielding. And then that switch on the right is welding versus grinding. So you would push that switch up when you're welding and slide it down when you're grinding, when you just want it to protect your face. What you can do is just to look up at the lights to make sure that it's working. And these are very cool because they have a little solar panel on the front that collects power from the welding action from that light and then automatically dims the screen. So you can leave this shield down while you're welding. You don't need to raise it up and down. So when you put the cap on, the cap goes backwards to cover the back of your neck and your ears. You leave your glasses on, and then the shield goes over your head. You loosen the knob in the back, and then tighten it, make it snug, and then you bring it down and up. The jacket is pretty straightforward. I'm just going to take this off so it doesn't get too hot. And any exposed skin will get a sunburn on it if you're welding for very long. So it's important to make sure that any skin you care about is covered up. And we have our gloves. Now we can go choose our metal. So we're doing mild steel. So we'll just grab these ER70S-6 filler rods. And for the settings on the machine, we are using the pedal. So here we're not using stick. We're gonna set this over to high frequency start TIG, DC. We're using the pedal. And right now we don't need to use pulse. We can just leave all these to 0. The pre-flow is set to reasonable. Post-flow looks reasonable. We're not pulsing, we're not AC, we're not stick, and we're not doing the spot welders. That's all off. And then really the only knob we need to worry about here is just the amount of current that it's putting out. And for what we're doing, you know, starting around here seems reasonable, and then you'll just play with it. So this is the maximum current that the machine will put out. So if you push the pedal all the way down, since this is around the current I want to use, I'm going to set a little higher so that we have more room to play. Then when we're pushing the pedal, we can see, you know, where it's actually making the best welds. So before we get started, we need to make sure that the material is very clean. That's important for TIG welding. So first, we just use some degreaser. This already looks pretty clean, but you know, couldn't hurt. Just on the surfaces that we'll be welding. Maybe do these surfaces. And then after degreasing, we use a brush on it to clean off anything else and grind into a little bit. And the brush needs to match the material we're using so we don't introduce impurities. So here's steel, which we'll be using on this mild steel material. And here. All right. This is obviously just, you know, an example. It doesn't look very reasonable. We're also going to dry off the table here so we don't accidentally shock ourselves by letting the electricity pass through a wet sleeve or something. All right, and it's nice that these come together very well. There's good fit up, so that we're not trying to fill a gap here. So we have our tungsten, looks pretty sharp. Have our grinder set up here so that if we stick the tungsten into the weld puddle, we can easily regrind it. We have our filler rods, except what I like to do, because these filler rods are a little unwieldy when they're so long, they come in 3-foot lengths, is just cut it in half so you have a more manageable length to work with. So here is a length that has been cut in half that I can take the the work clamp and clamp it right onto our material, just like that. Clamping onto the table is okay, but it's, the closer you can get it to where you're welding, the better your weld will be. Now, when you're welding, you want to be pushing, so leaning backwards relative to the direction you're moving it, about 15 degrees. So you want to have this in a spot where you can see what you're doing and you have your arms in a nice comfortable position. I currently have this cord going through my lap, so it's not pulling on my wrist, and there's a nice, I feel like I have a good view of what I'm doing. I can also elevate this if I wanted a better view. And you want to have your forearms or elbows resting on a surface. You can raise it up with some blocks underneath your arms, whatever you need to do to get it so you're in a nice comfortable position. So what I'm going to do is we're going to pulse in one spot and then pulse in another spot, pulse in another, moving along. Something you'll note is that you push the pedal, but because you set the pre-flow to a few seconds, it's going to be a few seconds before the arc actually initiates. As a reminder, if you do stick the tungsten in the weld pool, you'll notice, you can see that it won't be a sharp tip anymore, and then you just have to regrind it. And also as a note, with my foot, I'm starting at maybe a little higher power, so pushing a little farther down, just to get it nice and melty, and then I can let off a little bit as we start welding so you aren't overheating or blowing through. So you can see that I stopped when I was still over the molten weld to let it harden up with gas flowing over it. And I can glance over to the flow gauge on the argon tank to make sure that the gas is still in fact flowing. Sort of looking at this weld, it looks okay, but I think I need more power because this weld looks pretty proud. It looks high above the metal versus a little more flush into it. So now what I could do is go back over, we have a little extra metal there, and do a fusion weld where I'm just sort of melting it in to get it a little smoother and get deeper penetration. But that's the idea. I also think that my angle was too far back. I was probably closer to 45 degrees instead of just 15. So we can, go back over. You can see the coloration here. This is called the heat affected zone. So this area of discoloration is where the steel's molecular properties were changed. And so now it's a little more brittle there from having gotten so hot. So I'm just gonna demonstrate again, but the general idea is to start, let it heat up with the cone, and the distance you are dictates the size of the heated area. So closer isn't generally good. You wanna get it nice and hot right there, but too close obviously, and then you'll stick the tungsten in and have to regrind it. And don't be lazy about that, because it'll be your welds will just be totally crappy after you stick the tungsten. the arc will just be jumping all over the place and blowing left and right. So you really just at that point want to take it out and clean it. All right. So this isn't lined up quite as well as our past weld, but hopefully it's good enough. Fit up is very important. You want to spend as much time as possible getting it really nicely situated, so you aren't trying to fill a gap with your welding, you're just trying to put the two pieces of metal together. Alright, so they're together pretty well. And what I'm going to focus on is trying to keep the angle closer to 15 degrees. So hopefully we can, and I'll try to keep the heat a little higher to get a little flatter welds. Alright, so you can see here I focus with a little more heat and it is a little flatter, and you can tell in comparison that these are certainly a lot flatter than here. I was wandering a little bit, but you know, I think you get the idea. Then after you are done welding, there's a pretty basic cleanup procedure, nothing too crazy. So here we turned the machine off, hung all the cords back up, put the pedal away, turn the water cooler off, and turn the machine off on the switch in the back. And last but not least, turn the gas all the way off, because that is expensive and valuable. So make sure it doesn't escape on us. So this is definitely a type of welding that requires some practice. So I encourage you to practice what you saw here, but also, you know, keep playing with all the settings, various pulses and spot welding, learning how to weld aluminum and different materials. And I think you should have a lot of fun and be able to weld a lot of cool things together. So thanks for watching. I hope this was helpful.